Hello everyone, today I'm going to explain experiment number 4 exploratory data analysis using Python. The main objective of this experiment is to analyze of an employee dataset using Python libraries such as pandas, numpy, and so on. In this experiment, we perform different data processing and statistical operations. We can remove unwanted data, handle duplicate and missing values, calculate statistical measurements, visualize the data and identify and remove outliers. Now I will explain each question one by one. In the first question, we remove the senior management column from the employee dataset. We use the pandas drop-off function to remove the column. The axis equal to 1 parameter indicates that we are removing a column instead of a row. The in place equal to true parameter means that the change is directly applied to the original data frame. After remove the column, we use the header function to display the first five rows. The header function is useful for checking whether the column has been removed successfully. So the purpose of this step is to remove an irrelevant column and simplify the dataset for further analysis. Uh, Second question, remove duplicate rows. In the second question, we remove duplicate rows from the dataset. Duplicate rows are records that contain the same information more than once. We use the pandas drop underscore duplicates of function to remove these repeated records. After removing duplicates, we use the shape property to display the size of the data frame. The shape gives us two values, first the number of rows, second the number of columns. Removing duplicates is important because repeated records can affect the accuracy of our analysis. Um, in the third question, we rename the bonus column as incentive. We use the pandas rename function for this operation. Here, bonus is the old column name and incentive is a new column name. The in place equal to true parameter applies the change directly to the data frame. After renaming the column, we use head of to display the first sentence and verify the change. The purpose of this step is to give column a new, more suitable and meaningful name for analysis. In the fourth question, we remove rows containing missing values. Missing values are represented as NaN, which means not a number. Missing data can cause problems when performing statistical calculations and analysis. To remove the missing values, we use the pandas drop-now function. The in place equal to true parameter applies the operation directly to the data frame. After removing the missing values, we display the shape of the data frame. This helps us understand how many rows and columns remains after data cleaning. Therefore, this step is part of the data processing process. In the fifth question, we calculate the central tendency of the experiment column. Central tendency tells us about the central or typical values in the dataset. There are three important measures of central tendency: mean, median, and mode. First, we calculate the mean. Mean is the average of all the experiment values. It is the calculated by adding the all the values and dividing the total by the number of values. Second, we calculate the median. Median is the middle value when the data is arranged in ascending or descending order. Third, we calculate the mode. Mode is the value that occurs most frequency in the dataset. Therefore, mean, median, and mode helps us understand the typical experience values of employee. In the sixth question, we calculate the variability or dispersion of the experiments column. Variability tells us how spread out the data values are. First, we calculate the minimum value. It represents the smallest experience value in the dataset. Next, we calculate the maximum value. It represents the largest experiment value. Then we calculate the range. Range is calculated as range equal to maximum value minus minimum value. Next, we calculate variance. Variance means how much the value differ from the mean. Finally, we calculate standard deviation. Standard deviation tells us how far the values are generally spread from the mean. Therefore, this measurement helps us understand the variance in employee experiments. Seventh, we calculate the interquartile range, also called IQR. IQR is a measure of statistical dispersion. First, we calculate Q1, which is the first quarter or 25th percentile. Then we calculate Q3, which is the third quartile or 75th percentile. The formula for IQR is IQR equal to Q3 minus Q1. IQR represents the spread of the middle 50% of the data. IQR is also useful for detecting outlier. An outlier is a value that is significantly different from the other value. In the eighth question, we calculate the Z-score for the experience column. The Z-score tells us how far a particular value is from the mean in terms of standard deviation. The formula is Z-score equal to value minus mean divided by standard deviation. If the Z-score is 0, the value is equal to the mean. The positive z-score means the value is above the mean. The negative z-score means the value is below the mean. We create a new column called experience underscore z-score to store the calculated z-scores. This helps us identify value that may be unusually high or low. The ninth question, we create a correlation head map using salary, experience, and age. First, we calculate the correlation between these three variables. Correlations means the relationship between two variables. The relationship correlation value generally range from -1 to +1. A value close to +1 indicates a strong positive relationship. A value close to -1 indicates a strong negative relationship. A value close to 0 indicates a weak or no linear relationship. Then we use the Seaborn head map function to display the correlation value visually. The not equal to true parameter displays the numerical value inside the head map. The head map makes it easier to understand the relationship between salary, experience, and age. In the 10th question, we add two new employee records to the data frame. First, we create a dictionary containing the details of the first employee. Then, we create another dictionary containing the details of the second employee. This dictionary contains information such as first name, gender, team, age, experience, salary, new salary, and incentive. Next, we convert the two dictionaries into a data frame. Then, we use the pandas scancat function to combine the new records with the existing data frame. The ignore underscore index equal to true parameter reset the row numbering. Finally, we use the tail of function to display the last 5 rows. This allows us to verify that the two new records have been added successfully. In the 11th question, we replace missing values in the salary column with the mean salary. First, we calculate the average salary using a mean function. Then, we use the fillna function to replace missing salary values with the calculated mean. This is called mean imputation. Instead of deleting the entire employer records, we fill the missing salary with the average salary of the available records. After replacing the missing values, we use tail of to display the last 5 rows and verify the result. In the 12th question, we identify possible quartile outlier in the experience column using a box plot. A box plot is a statistical graph used to show the distribution of numerical data. It displays important values such as minimum first quartile, median third quartile, and maximum. It can also show possible outlier. An outlier is a value that is unusual, different from the majority of the data. We use matplotlib box plot function to create the graph. The graph helps us visually understand the distribution of employee experience and identify unusual values. In the 13th question, we remove outlier using the IQR method. First, we create a copy of the original data frame using df.copy. Creating a copy is important because we don't want to change the original data. Next, we calculate Q1 and Q3. Then we calculate IQR using IQR equal to Q3 minus Q1. After that, we calculate the lower and upper limit. The lower limit is minus Q1 minus 1.5 multiplied by IQR. The upper limit is Q3 plus 1.5 multiplied by 1QR. Values below the lower limit or above the upper limit are treated as outlier. We remove those values from the copy data frame. After removing the outlier, we calculate Q1, Q3 and IQR again. Finally, we create another box plot to analyze the experience data after removing the outlier. In the 14th question, we remove outlier using the Score method. Again, we create a copy of the original data frame using DF copy. First, we calculate the mean and standard deviation of the experience. Then we calculate the score of every experience value. The commonly used rule is that value with the absolute zero score greater than 3 can be considered extreme outlier. Therefore, we keep values those absolute score is less than or equal to 3. After removing the outlier, we calculate the mean and standard deviation again. Then we recalculate the score using the cleaned data. Finally, we use a box plot to visualize the experience values after removing the score outlier. This allows us to compare the data before and after outlier removal. In the final question, we remove the two employee record that we added in question 10. We use the tail of two function to select the last two rows. The index property gets the indexes of those rows. Then the drop-off function removes them from the data frame. Finally, we use tail-off to display the last 5 rows and shape to display the final size of the data frame. This brings the data set back to the previous state before the two temporary rows were added. To conclude, this experiment demonstrates the complete process of exploratory data analysis. First, we clean the employee dataset by removing irrelevant columns, duplicates, and missing values. Next, we calculate statistical measures such as mean, median, mode, range, variance, standard deviation, IQ, and indices score. Then we visualize the data using a correlation head map and box plots. Finally, we identify and remove outlier using both the IQR method and the score method. For exploited data analysis help us understand and the structure, relationship patterns and unusual values in the dataset before using it for further analysis or machine learning. Thank you.